My name is Scott Warren. I am your host for this podcast and the ITFORUM moderator, now going for 3 years. We are now fully back up and running, and I appreciate everybody's patience. It wouldn't be instructional technology if there weren't challenges, and this has been quite the challenge. This is something new that we're doing here for ITFORUM to give the authors the opportunity to talk about what they do and get some of the history on these folks and really make the authors that we read in the texts human so that we can understand where they're coming from. What is it that influenced them? To give authors, both new and old, the opportunity to really get to speak for themselves in a way that we might only get to do at conferences. With these podcasts, if you have any ideas or thoughts or recommendations for questions that you'd maybe like to ask the author or have me ask the author, I will put out a call maybe a week ahead of time for any questions that those of you out there in the community are interested in asking, because this month we have Dr. Joseph Scandura. I'm hoping to have Dr. Charles Reigluth next month, who is one of my professors back in Indiana more than a decade ago now, and to get the opportunity to really ask questions that you might not be comfortable doing, even if you're around them or just don't have the opportunity to do because we're all so busy. I think this is a really nice opportunity to do so. So, this is the first podcast, and I apologize if there are any oddities or anything else, but my main influence has been listening to Nerdist-style podcasts, and I'm hoping that it is something that you all enjoy. I know I did. Welcome to the very first ITFORUM podcast. I am fortunate enough today to have Dr. Joseph Scandura. He currently serves as Director of Research for Tutor at Web. He is an emeritus professor from the University of Pennsylvania and the editor-in-chief of Technology, Instruction, Cognition, and Learning, the journal lovingly known as Tickle. And we tried doing this podcast a few days ago and had some technical difficulties. I am your host for the podcast, the ITFORUM moderator, Scott Warren, associate professor at the University of North Texas. And the paper discussion for this week has been offered by Dr. Scandura. It is Author It and Tutor It, an intelligent tutor authoring and delivery system you can use. So my first question to you is, what drew you to the field of education generally, and more specifically into learning technologies, as we call it here, or more broadly, educational technology?
I guess the way I started, the thing that had the most influence on me early on was my math and science teachers in high school, who also happened to be the coaches, football and wrestling coaches. And those were areas that I was very interested in, both ends. And frankly, the math and science came very easy. And consequently, I guess I was sort of a star in those courses. But at the same time, as I say, at that point, the athletics was more encompassing, took over my life, so to speak. I put an awful lot of work into it, actually continued into college and so on. And what happened is, really starting from this foundation or this background, I just naturally evolved into the teaching field. And it was not something that I had planned. It just seemed to be a very natural series of events that kind of led me in that direction, namely into math and science, and also the athletics, which I was doing for quite a number of years. Actually, I was getting my PhD, and beyond, I was also the head wrestling coach at Syracuse University, for example. And but the work, as I say, just led very naturally. It just didn't seem to be any transitions. I was in school. I was doing well in school. Never brought a book home in high school, by the way. It was sort of a thing that you had to be star student in the areas, but you couldn't work hard. And that was just the way it was at those times. And essentially, that's pretty much how I got started in it. And as I said, I went on into my dissertation research and so on. And there it was graduate work in mathematics. But I found myself increasingly going on in mathematics, more interested in how people learn mathematics and the thinking processes and so on, and why it was easy for some people like myself and not so easy for others. And that just basically was turned into a topic for my dissertation. The main outcome of that research, or the main conclusions, it was a 3-year period, so it was pretty intensive research. During the heyday of the new math, when everybody was talking about the importance of discovery learning, that somehow if you discovered things, that somehow that was better than if you were told how to solve problems, or told explain some concept was explained to you. In any case, what we found was far more important than how you learned something, whether you learned it by discovery or whether you would learn by an expository teaching, was what you knew at the time information was given. If you received information that was too soon, you couldn't use it, didn't know what was going on. If you received information too late, people would get frustrated, students would get frustrated, and they're not able to go ahead. And that information, the important thing really was what needed to be learned to be successful. And that is essentially something a theme that's followed through in research over the years, over a period of over a couple hundred articles, 8 books, and so on. But the common theme, obviously, there's a lot of forays and diversions and things of that sort, but the basic conclusion was really something that followed through over a period of decades, actually. And I think we're at a point now, finally, it seems like a long way around, but essentially to make those ideas very precise. And we've got them down to a point now where we have been able to build dynamically adaptive tutoring systems, which build essentially on that basic theme. That is, providing the information a student needs at each point in time and continuing that process from where they begin, step by step through full mastery. And in fact, we're at a point now where we're quite confident that we can, in fact, guarantee mastery by essentially doing exactly that. That is, we start with a representation of what needs to be learned for success. We use that representation as a measuring device, if you will, to find out what the student does and doesn't know at each point in time, give them exactly what they need or precisely what they need to progress, whether that's done by a purely discovery or whether it's done by expository methods, really is a secondary issue. Expository, if you really know what it is, it can be done more efficiently, obviously, because you're doing it directly. The student doesn't waste a lot of time. And one problem that people, I think, ignore in the discovery learning area, or taking that approach, is that if you expect the student to have to discover things and they get frustrated, that certainly doesn't serve any learning purpose. I don't know, is that, I mean, I could go on here, obviously, and just talk about this, but I don't want to digress from what you have in mind, Scott.
No, that's exactly what I have in mind. This is exactly the kind of things that, for me, some of what you're talking about, for a lot of the folks that are like me in the field, and some of what you're talking about, this is foundational. This is the things we don't know about, the things that aren't written down in books, the history of our field. This is some of what you're talking about happened before I was born, and so I just don't have access to it. I was born in '74, so new math was one of those things that they made jokes about when I was in elementary school. So to have that context is really important to understand where we come from and where we're going. And it also provides additional context for what I've done in my own work. When you're talking about having this transfer, having these tutoring systems set up, a lot of this, when I build, I try to use similar kinds of underlying constructs, partly because that's what the technology allows. I do conditional responses when I design games for learning for students. And a lot of that, you read about it in the textbooks, and people just kind of talk about it as though it came out fully formed and awesome, and no one actually was back there working on it. They talk about it as something that's just accepted fact without the history that allows us to understand from where it evolved. So this is fantastic.
Well, let me let you just carry on here. I mean, obviously, I could kind of go on and just sort of talk more about the whole process, but the thing in my own work, especially when I got into my dissertation work and thereafter, there were certain people that had an influence on my thinking, and they ranged from people like Dinas, who is a mathematician who put a lot of emphasis on education or math education. Pat Supes was sort of on the other side of things, was a logician. There were other mathematicians. There were Bob Gagne on the other end of things, who was a psychologist. There were people in linguistics that were doing work, cybernetics, people like Gordon Pask. And they were doing fundamental work coming at the same set of problems from fundamentally different directions. And in my own field, I kind of dabbled around, basically. I had the problem. I knew what the problem was fairly early on, or at least that's what I was fascinated with. That's what I was trying to understand. And I spent a lot of time searching for the best theoretical foundation for that work, and it didn't exist. There were people in SR psychology looking at a part of the problem. I did a lot of research in experimental psychology, mathematical psychology, and so on in those days. And I did work in mathematics. I did work in linguistics type of research. And what did linguistics bring to it? Not so much the details of linguistics, but the methods. They were very concerned with basically essentially what needed to be learned, or what did you really learn, or what needed to be learned to be good with language. And essentially the same ideas occurred to me that were equally applicable across the board to all subjects. And I remember early days, you would talk with people in psychology, and to them the tasks weren't really important. It was sort of things like number of repetitions and how much time you spend and that sort of thing, or whether content was difficult, easy, or somewhere in between. And they really didn't pay much attention to the actual structure of the content itself. Conversely, the people in the subject areas didn't pay much attention to the psychological aspects, or what needed to be learned, and when information was given at what point in time, and what different differential impacts it would have. And to me, I found myself bouncing back and forth between these two frames of ways of thinking, and essentially came up with my own approach, which was essentially an integration of the two. I always had the feeling that, for example, I guess classical physics was sort of the model that had the biggest impact on my thinking. Some of the newer stuff, dealing with quantum theory and that sort of thing, where things are very sort of unpredictable, to put it in the simplest possible way, where you don't know when things are going to happen. When things happen at a distance, something over here is having some simultaneous effect in a distant planet, so to speak. And literally, that's the way they're talking in many ways.
Yes.
It was not that kind of thinking, but what was basically what the model that had the most influence on me was the kind of thinking that went into things ranging from Copernican theory to Newton's theory and so on, where there was a foundation which seemed beautiful. It was clean. It carried and covered all of the things, or a wide variety of the things that physics could explain. And that was the kind of thing that I took as sort of a model that I wanted to deal with. My first book, Deterministic Theorizing and Structural Learning, after a period of research and so on, and discovery learning and expository learning and rule learning, and even some work in experimental psychology, the basic thing was is that observable behavior was the data that we had to deal with. And so we were concerned with the behavior, the observable data, and then the question became, how do we represent and how do we address the knowledge that's necessary, what's behind that behavior, what's necessary, what's is responsible for the production of the behavior that we can observe. And as I say, it was a very complex problem, and the goal was to understand that and to formalize it. My mathematical background sort of forced me to say, wait a minute, mathematics is great, it's wonderful, we should be able to take any set of ideas and formalize it and represent it very precisely and so on. The problem was it was very difficult, and there was really no mathematics that really fit the problem exactly. We tried things ranging from category theory, ended up after, which is a very esoteric branch of mathematics. I mean, calculus certainly didn't work. It wasn't relevant. Things like pretty much a wide variety of ideas at that time, and we didn't have any luck finding. We finally settled on directed graphs, which are similar to flow charts and so on, and not that far from programming. And that was the original model that we settled on. But it had certain problems, and the basic problem was, if you think about it from our standpoint, that is instructional design, the biggest distinction that still carries through in many ways is the distinction between procedural knowledge on the one hand and factual knowledge on the other hand. Factual knowledge tends to be automatic, and so you're given a problem, you get an answer immediately. Procedural knowledge is more systematic knowledge, and so on. And then you had people like, and I don't mean to overly complicate, but they had people in the ITS, Intelligent Tutoring System community, where they were basically saying that when you proceduralize knowledge, you're actually, that's the automatic knowledge. In fact, what they were doing is exactly the opposite of what we finally came to the conclusion, that in fact procedural knowledge leads to automatization and or the conceptual or the what you call the factual or declarative knowledge. So there's a lot of sort of fundamental differences in terms of the way in which we were approaching the problem. I feel like I'm rambling.
No, not at all. No, it's I'm actually taking notes as you talk. Part of this, I'm fascinated, especially by the linguistic component of this. Partly, I was an English teacher as well as a social studies teacher before I got into all of this. And so this procedural and declarative concepts are kind of central to a lot of what I've done in the past. And I do a lot of linguistic analysis for my own research. So that this then leads into things like computational linguistics. And it sounds like the structural analytic approaches that have come out of that sound like they match up fairly well. Is that something that you use with the author it and tutor it systems?
Well, it's very basic to what we're doing in author it and tutor it, and I think maybe I may just say a couple words about that background. I think in the sense of tutor it, not tutor it, but in representing knowledge, one of the big questions and one of the concerns that people in intelligent tutoring systems have had and so on, what is the appropriate level of representation? And what they're doing is they're starting with productions, for example, and they make assumptions about what are the productions that govern. These are sort of if this, then that. What's this under these conditions? You do X, Y, Z. They have to make assumptions about all the productions. They have to make assumptions about the mechanisms by which those productions are put to use in producing behavior. It's a very complex task, and recent research by actually proponents in that field have recognized that they miss about 70% of what's important. If you start with a given domain, you try to identify the productions that are necessary for success in that domain, together with the control mechanisms which govern how those things are put together. They literally are missing 70% of what's important. That's not a very encouraging, I think, conclusion, and it's their conclusion. And this came up after 30, 40 years of work in that area. And to me, it never seemed to be the right way to go, but the terminology overlapped in many ways that were both fields were using. And because of that, there's been, I think, a long-term confusion in the field between them. I think essentially one way to look at what they were doing is, and I think they've recognized this in recent years, is finding the appropriate level of representation or detail is a very critical problem, which they have not solved. What it turns out, we started from the other side. They were working at things at a very precise level. And I could give a little side story here, but let me go back to the other. And from the bottom up, they were essentially working, but we were working essentially from the top down. The problem from the top down is that you can be generally correct, but you don't have the same degree of detail. So the challenge was really how to take what we felt was conceptually correct and make it as precise and rigorous as working from the bottom up, which by its very nature was precise. And it goes back to an early experiences I had starting out with some of the people I was talking about, mathematicians and logicians and things of that sort, along with the psychologists. Pat Subies I'll use as an example. Pat was a very bright guy, those who knew him, was a logician and so on. And his view of science was that you made very precise assumptions in your theories. Why? Because you could prove them wrong very easily. And as he would put it, he'd rather be precisely wrong than vaguely right. There were others that took an opposite point of view. They weren't necessarily theorists, but people like Gaines, for example, and I would put myself in that camp, wanted to be at least vaguely right before we even started. Because if we weren't vaguely right, we were doing the wrong thing or working on the wrong problem. Mm-hmm. The problem was, how do you even take that vague, being correct in a vague sort of way, as precise? And that was the biggest challenge that we've had in our work over the years. We were able to do things, higher order knowledge and procedural knowledge and conceptual knowledge and factual knowledge and problem solving, all were represented within a common framework. And as I say, we used flow charts, procedures, and that sort of thing. That was a fairly uniform way of representing the knowledge. The thing that was lacking in that was the ability to represent different levels of expertise. In effect, you had to choose the level of representation that made sense in the environment. And what we did, this came out only after leaving leaving the work that we were doing largely in education, foray into software engineering, which was supposed to last about 6 months or a year at most, to shore up some of the theoretical foundations, actually turned out to take more like 15 or 20. But in any case, the main result of that work was that we were able to change the theoretical foundations on which we use to represent knowledge or what needs to be learned for success. And the shift was basically from directed graphs or flow charts, which requires a certain level of representation, to abstract syntax trees, which are very different in the sense that you can start from the very top and represent knowledge with arbitrary degrees of precision. What that means is that you can be vaguely right and vaguely correct, and also precise, and as precise as you need and want to be. That common representation in terms of these abstract syntax trees has played a major role in making it possible to build the authored and tutored systems that we have today.
That makes a lot of sense. That leads me to something. When you talk about this, you talk about in the context of wanting to be more likely right and starting from a position of that. And part of what we try to do in our field as we reify knowledge as we conduct research is we're kind of creating snapshots of processes that tend to always be in motion, leading to this idea that because we can't always predict how the teacher or the learner are going to respond, or how they're going to respond in a classroom, because good teachers respond to conditions on the ground. They respond to what an individual or a group of learners needs at any given time. Therefore, any attempt to create a model of teaching or learning when we're talking about a process that is literally always in motion, we can get snapshots and we can build a picture. It may be a motion picture, but maybe we get one out of every 24 frames of that movie. And so we're trying to build a case for the probability that our model is going to be correct more often than not, but at the same time recognizing that because we're not really in control of the outcomes the people using the models are, we're talking about probabilities rather than certainties. And so we have to build these into the models that we create.
I think that scenario and that truism actually reminds me very much of when I did do some practice teaching. Actually, I only taught for a couple of years, but it had a formative effect on my thinking. And I can remember going back to an old elementary school teacher, actually a kindergarten teacher of mine. And the thing that came across to me so clearly in that case was the way she managed the classroom. She would be going along and be talking about something in mathematics, and she would sense in 5 or 10 minutes a little bit of uneasiness, and she would flip into something else. And it was just flipping back and forth, almost like playing an orchestra with the young children and so on, and keeping them engaged and active, sensing when they were a bit too tired to continue thinking about a certain thing, and they were ready to move on. And it was that sort of thing, as I say, literally playing an orchestra. That kind of thing would be very, very difficult to automate. And I'm not sure that that really is where we need to go at this point in time. What we've been doing, basically, is essentially saying the following. We want to automate what can and should be automated at this point in time, and leave to humans the kinds of things that they are better at. And it goes back to the following, I think. Artificial intelligence, people were thinking, oh my gosh, we're going to just automate everything. We're going to make people obsolete and so on. And yes, they can play chess better than they're now beating masters. It's wonderful. And the thing is that the number of possibilities there is sufficiently small that they can analyze with sufficiently powerful computers all the possibilities and so on, and they've gotten more and more powerful and better able to do that. The thing, however, is that what they've found, even in most complex cases, the best decisions are made by combinations of computers and human judgment. And really what's going on, and this maybe to go off here, it's a little bit on a tangent, Scott, but it reminds me of the very important distinction between the approach we're taking in automating the tutoring process and what is going on in what we call adaptive learning. Adaptive learning is basically the biggest impact or the main dominant approach in that. It started out as intelligent tutoring systems, but for the reasons that I indicated, they leave out too much. There are gaps there, there are problems there, and even the people who developed that work at Carnegie Mellon, and they sold it to Carnegie Learning, and Carnegie Learning went to, I guess, where they're working with right now, Apollo. And Apollo is taking them over. But the changes that they have made, initially in that program, they used intelligent tutoring systems to teach the procedural knowledge. When they got to the factual knowledge, which they had to teach, they have reams of textbooks and so on. And so they couldn't even, with their model, teach a major part of what needed to be part of any given curriculum. So, but having said that, from my perspective, that approach is, I don't want to say been a failure, but it has been largely a failure. There was a $6 million study by the RAND Corporation, and all they did was evaluate the results of millions of dollars that went into developing intelligent tutoring systems. What they found was, after the first year, there was essentially no difference, and I think the second year they had a minor 5 or 6, 8% gain over the others. And from my perspective, a very small payoff, if any, for the amount of money that was invested in it. The alternative and what's going on today is basically based on big data, and big data is, as you know, modeled on the Google type phenomenon. And the example I like to use when you talk about Google, and I use it myself every day, and most of us do. We want to get some information that we're not sure of, or we don't remember something, or we're trying to find out what's going on in XYZ field. We go out and we do some searches, and we get a lot of good information. But who makes the decision as to what's important? But the human does. At least I do, and I'm sure you do, and everyone else. You look at what's available there, and you say, okay, I want to like it. No, that's not really what I want. This is more like it. You keep searching around until you get the information you need. Maybe you have to change the search terms and things like that. Those are decisions that the human's making, the computer is not making. And in the same way, the current tutoring systems, adaptive learning systems, so-called, people like, you're familiar with Newton, for example. Yes. I've got literally millions of dollars have been invested in them, and so on. But what are they doing? What they're doing is they're essentially wanting to automate all the decisions that are made by a tutoring system. They're not tutoring system. I shouldn't use that word. Their adaptive learning system as they interact with the student. But they're making all decisions, or attempting to make all decisions automatically. And the way they're making them is they test a student, for example, on a problem. The student gets it right. Well, to them, that means the student knows that material, is a good person, knows that subject. So let's give him something that's more difficult. If he gets it wrong, let's give him something that people on average find easier. And again, it's on average. I want to stress that, because they're basically measuring how that student is doing relative to a large amount of data which they've accumulated or are accumulating dynamically in a big, large database, or databases, interrelated databases, and essentially using that to make the decisions as to what to teach next. That's fine in general and on average, but does it really meet the needs of any particular student in any particular content area? And what we found, and the model that we're working on, is we are working with teachers, and we still want teachers to have the control that they can uniquely provide. It's the sort of thing we talked about, of shifting between one thing and another based on the needs of the students at a given point in time. But then there are things like learning how to do long division, or learning how to solve linear equations, or learning how to just basic facts. These are all things that we want the students to learn. And we can, once we've identified them as a teacher, we can effectively not only find automated tools, and that's what we're doing. We're developing tools that will do it, not as well as a typical teacher, but better than an actual teacher. And the reason we think we can do it better is because the tutoring systems are based on a detailed analysis of what needs to be learned for success on that set of problems, or that domain. As I say, it could be column subtraction, it could be long division, it could be solving linear equations, it could be whatever you define. And so our goal is basically to make that as precise as we can, to be able to give that to our tutoring system, and our tutoring system will in fact then do its job, essentially making sure that every student who completes that tutorial will have demonstrated mastery of the content. So it's not a question of doing better or worse. It's a matter of, by definition almost, if they finish that tutorial, they will have demonstrated mastery. And this idea of guaranteed learning, I think, is very much within reach. If the main questions are, did you do a thorough analysis? Did you break it down far enough to make contact with the weakest students in the intended population? And if you've done those things, and you've done a good job with the teaching and so on, any student who finishes will, by definition, have demonstrated mastery. If they don't finish, of course, they will not. So the challenge is, of course, in addition to doing a detailed analysis, is to make sure that the instruction that's associated with it is sufficiently motivating that the student will be motivated to complete that tutorial.
That makes a lot of sense. Thinking about that in the context of, to paraphrase kind of a Buddhist concept, that some of what you're trying to automate are the things that are too time consuming and too difficult for the teacher to be able to do for every single student, to be able to line up exactly what each student needs. Because, and as you know and I know, teachers spend 12, 14, 16 hours a day working, even though they're paid for 6 or 7. And so they can't really attend to literally everything the way that they do in the classroom. You just reach a point of mental exhaustion from having to do all of that. But in the classroom, the really good teachers are attending to everything. They have eyes in the back of their head, as some people will say. You get that amazing teacher peripheral vision where you can tell that Johnny is messing around over there, and you can bring them back to attention. But a computer doesn't know that they're not paying attention. But a computer is very good at determining, okay, if they're not learning this in this way, here's an alternative method by which this could be done, or here's the best way to teach this particular concept. But at the same time, that can also help the teacher know when a student is having trouble and needs reteaching, and then the system can help reteach those concepts without that mental exhaustion that the teacher might face, so that they can attend to other things.
Yeah, I think that's exactly right. I think the key thing is to let the teacher do what they can do better than any computer system, simply because they're attending to these little fine grained observations and so on, and frankly putting sensors on kids' heads and so on is never going to get to that same level that a teacher can do intuitively, and in fact should intuitively. What can be automated are the teacher says this kid needs some help in XYZ, or I want him to make sure he knows how to do long division, whatever it happens to be. If we can have a tutoring system, which we think we have, that will take that student, find out what they know, what they don't know, and will work with them until they demonstrate mastery of that content, and putting that together with the teacher's judgment then as to what to do next and that sort of thing, or how to organize these individual tutorials into the full curriculum or partial curriculum or whatever they choose, is sort of optimizing the best of what the teacher has along with the automation that makes it possible.
It gets to a larger philosophical concept for me. Going back to what you mentioned about the Newton issue, where they wanted to automate literally everything. What I've found with the systems that try to do that, things like my IT lab and my math lab, is that automaticity becomes the enemy of mindfulness, and the best teachers tend to be very mindful. They're mindful of what each student needs. They're constantly assessing those kinds of things that a particular student needs from a classroom management perspective, from an affective support perspective, from an organizational classroom perspective. But if you try to automate everything, that can lead to a one-size-fits-all model a lot of the time, where the claim is that the system is set up and everyone can learn in the same way at all times. But it sounds like with this system, it adapts to the individual a lot more. So it takes some of the pressure off the teacher, which I know as classroom sizes continue to increase, that's a pretty big issue.
Well, ideally, it would be great, of course, if we had an opportunity to sort of share screens and things like that, so that we could kind of demonstrate how this stuff works. But essentially, you can think of it as an automated, intelligent tutor who knows exactly what the student needs to learn to be successful at all levels of expertise. And what I mean by that is there are knowing all the steps, all the decisions individually are one thing, and being able to carry it out is one level, represents one level, or one of many levels of expertise or of knowledge. Ideally, there are some things that you want the student to know so well that they can do them automatically. And indeed, the kind of tutoring systems or tutorate is designed to deal exactly with that problem, so that it will work with the child at whatever level of expertise they are currently functioning at. And it will take them through to full mastery, not only being able to solve all of an entire class of problems, but to be able to solve those problems at any desired level of expertise. And what do I mean by that? For example, you could give a child a fixed subtraction problem, and the child might be able to go through any subtraction problem and get the right answer. Go to the first column, subtract. If the top number is greater than the bottom number, you just subtract. If it's not, then you have to go regroup from the next column. And if the next column has zeros in it, you have to go further over it, and so on. And increasingly complex kind of sets of decisions to solve such a problem. As a person gains expertise, a lot of the details drop out, or can drop out. So the student can now not just have to go through all the steps individually, but they can automate many of those steps. So now they can do it in bigger chunks, if you will. So now they're not solving it step by step any longer, but they're doing it in partial problems in this sector. They were able to even look at a problem, many problems, and just say, oh, the answer is X, Y, Z. Why? Because they've already mastered the detailed steps and decisions that have to be made, and now they've got it to a point where they know the answers to many questions just automatically, and they immediately solve the problems. And that's a very common theme with essentially learning almost anything. That you can start, you can go through the process in a very systematic, detailed way, but experts do these things very quickly. And this is one of the things that the structured learning theory and work that we've been building on explicitly addresses, is that process of moving from a neophyte stage, so to speak, through the increasing degrees of mastery. I don't know if that's helpful a little bit.
That's extremely helpful. I was thinking about this in the context of those problems. One of my least favorite things as a math student in my younger years was word problems. But it tends to offer a lot of context, and often we think about these contexts as allowing for transfer more meaningfully because they represent situations we might find out in the real world. And so for me, because I design a lot for literacy, I try to design situations in which the learning tasks, as well as the language that's used in the problems that are presented, has a level of authenticity to it. Is that something, as these problems are created in these systems, that you study in order to help try to improve that?
I'm not sure I'm getting the question, Scott. Could you?
Absolutely. So whenever I'm going to give a student a problem in, say, a writing context where I want them to respond to a particular prompt, I want them to investigate something. So with Anytown and Chalk House and some of the other games that I built, students role play an investigative reporter because that's an authentic activity for writing that someone might do. It's something that requires a lot of reading. It requires investigation. It requires that you gather a lot of information so that you can engage in writing. You have to engage in reading comprehension. You have to have a high enough vocabulary to have that reading comprehension work. You have to have other skills. And so the problems that I try to construct have a level of authenticity to them, because that allows students to transfer between what they're doing in the system out to authentic contexts out in the real world. And so when you're studying this, because you mentioned linguistic analysis before, as these problems are created in the system for doing the tutoring, is that something that you consider as these problems are constructed to help improve transfer between what they're doing in the system and what they're doing in the real world?
Yeah, let me kind of comment in that context. There's a couple of issues that come up that I think are very important. When you start talking about the kinds of tasks that you're talking about here, or jobs to be done, so to speak, a lot depends on what the kinds of responses that an automated system, a tutoring system, can engage in. For example, tutoring's quite rich. A lot of systems basically use multiple choice or yes, no, and that's pretty much all they can base their decisions on. Others you can get, for example, an exact answer and so on. It can evaluate that as correct or incorrect. In tutoring, we do those things. We also can evaluate things like clicks on the screen, where you click to point out the largest XYZ or whatever it is, and they click on the correct one. You know that. So we've got a fairly rich set of response types that we can evaluate. You can even have a student construct things, take various objects, for example, and arrange them in various ways to answer a particular question. One thing we don't do now, but could do eventually, using speech recognition technology. We do use text-to-speech, so on, so that it makes it easy for the tutor to perform. But the question of speech recognition, we haven't introduced that. We could. There's technology for that, and at some point we probably will. There's a problem, however, that goes beyond, and I think it's related to the kinds of things you were talking about, and that is, how do you evaluate responses that are very complex, relatively complex, that really require human judgment? For example, it'd be very hard to have a student write a paragraph and as an answer to a question, and then properly evaluate that paragraph in a way that a good human tutor or teacher might do. So there are some things that I think teachers will be better at for a long period. Now, I know there's some advanced research trying to analyze answers or paragraphs or even short stories, perhaps, and that sort of thing, whether they're good, bad, or indifferent. But that's a very specialized technical task, and is hardly reached the point where it's possible to use those as just one part, because that's what they are, just one part of a tutoring system. So it's basically the evaluation capabilities of the system and whether it's able or not able to do the needed analysis. Does that help a little bit?
Yeah, absolutely. Yeah, definitely.
Yeah. The other thing that's related to that, I think, is the interaction. For example, if you want to make it still more complicated in a tutoring environment, and a human tutor can talk with the student, and the student can ask a question, and then the tutor can go off and deal with that, even if that question has nothing to do with the domain in question. So you might be teaching long division, and the tutor or the student gets sidetracked and starts talking about his Aunt Tilly did such and such a thing, and the tutor responds in a human-like way and answers that question. It may even have some educational value. That's the kind of thing that a human can do, that kind of broad judgment, that ability to jump out of context and back in and so on, that no automated tutor is going to do.
Yeah, definitely. And that reminds me of Amy Baylor's work with intelligent agents going back to the late 90s, because she was looking at these physical representations, these avatar representations, to look at what kids respected, like what did they need to look like in order for them to believe that they had expertise and things like that. But by removing that, you don't really have to worry about it. And I'm torn sometimes because I'm very much into narrative and the need to hang things on narrative. But at the same time, with tutoring on specific tasks, I almost feel like the narrative and some of the visual representations might impede someone's ability to learn.
I think one of the things we're talking about here is that there are a lot of things that are not really, it's not really feasible today to automate, nor perhaps should we. I think theoretically, work on conversation theory, for example, that Gordon Past was well known for, and that we were actually have a theoretical foundation for it. There are many things in the structured learning theory that are not yet implemented in Tutor It or Author It. And the reason is that just very sophisticated, very complex, and they theoretically could deal with this kind of interaction and conversation, if you will, between two agents. It would require additional work and, frankly, a lot more money than we've got to put into it ourselves. So, in future years, I can definitely see that as a natural evolution of the kind of work we're doing. We're not there now, and right now there's so much that can be done with the technologies that we have. That has to be, pragmatically has to be the first step. On the other hand, from the standpoint of the underlying theory, structured learning theory on which this rests, the extensions are there. It's a matter of how much can one do at a given point in time with the resources that are available. And toward that end, Scott, I would want to take this opportunity to invite listeners, authors, for example, who may be interested in building some of these dynamically adaptive tutoring systems. Right now, we have the Author It platform. Really consists of, there are three basic platforms, actually four. One we call Easy Author, which is a tutoring system which is designed to make it possible to create adaptive tutoring systems for content such as class tests, SAT prep, GRE, law boards, anything of that sort where you have a set of questions or items that need to be learned. And they're more or less independent. They're large numbers of things testing a large corpus of knowledge and so on. And you want a tutoring system that will teach that knowledge in the most efficient way, meaning that if the student knows it, stuff's going to drop out. When they don't achieve mastery or a desired level of mastery on it, they'll keep being tutored on it until they do demonstrate that degree of mastery. And developing that kind of system actually is quite simple. We've actually built a fair number of them, and the technology and fine-tuning the technology to make it possible for other people to build them. And indeed, that's going to be critical because we're not experts in every subject matter, nor is that our special claim to fame, so to speak. It's basically the technologies that will enable other authors, instructional designers, and so on, who have expertise, or subject matter experts, who have expertise in given domains of knowledge and want to create tutoring systems that will help them or automatically convey what they know to students and to do that automatically. So anyway, that's easy. We've also used the desktop application called Author It to build a wide variety of tutorials, mostly math, but not entirely. We've also done it with critical reading, for example, of tutorials that will systematically identify what any given student does and does not know at each point in time, and will take them systematically from where they are through to full mastery. It'll keep interacting with the student, making sure that finding out whether they know something or don't know that. If they know it, fine, it'll be able to move forward. If they don't know it, it'll provide instruction and make sure that they've learned it before it progresses, and it will continue that process until they demonstrate full mastery. So we have quite a variety of things ranging from basic facts and in arithmetic, for example, through the whole number of arithmetic, through fractions, through decimals, algebra, basically up into beginning college algebra, for example. So there's quite a wide variety of them. There's also the critical reading, and we've got a lot of examples or samples of things showing how other things can be done. So the one thing we can do with some of these adaptive tutorials that we've built is that we can have an author, for example, can take them and customize them. By customizing, I mean they can take the core technology, they can enrich them by adding their own videos, their own YouTube videos, their own personal ones, their own voice, changing the wording, improving the explanations, etc., etc. So they can take existing tutorials that have been developed professionally and essentially enhance them. And then, of course, there's the more sophisticated work where you're actually building these tutorials. And the fourth area of authoring that we have, the fourth authoring system that we have, is one that enables an author to very easily, or even a teacher, to put these existing tutorials together to form a whole curriculum. So, for example, you can put these tutorials, arrange them hierarchically, for example, so that a student could begin with the tutorial and would start wherever they test it out at, so to speak, and continue the process through what might be a full curriculum until they demonstrate mastery using the existing tutorials. So essentially, in short, we're very open to that, and if any of the people who engage or listen to this are interested, I think the best thing to do is to contact us and let us know that they are interested. We are making, our plan is to make the authoring systems available at no cost to authors. They would be used for research purposes. They could be used for developing what they hope would be professional quality tutorials that students can be using. We will, and we're even planning, Scott, to make tutoring available for use to teachers in schools in a classroom setting, at no cost. Of course, we do have to get some money someplace, so there's either got to be some grants or indirectly from individual users, because the technology is a very complex technology. It requires very powerful server to support this, and this takes a lot of time and effort and money to do that. So what we are, however, able to do at this point, we're exploring this. We don't know for sure how this will work, but what our plan is to make the tutorials available to teachers for use in the classroom setting, so that they would be able, for example, if they want to teach fractions, they could take our tutorials and have it run in a classroom setting. Problems would come up, students would answer the questions, and based on correct or wrong, it would make the appropriate judgments. The difference is you can think of it as an automated lesson plan that could complement the teacher. These tutorials are supplemented in many cases by, for example, YouTube videos and so on. We just add a human element to them, if you will, and where teachers can supplement as they wish. But the core of the core knowledge that needs to be mastered for success is very thoroughly analyzed and so on, and provides assurance that every student who finishes and goes through that will have mastered it. Now, of course, in a classroom setting, if you call on all the bright kids will definitely get it. The slower kids will not. What a good teacher often does is they choose students according to where they think they will be in this process, and again, they can choose the weaker students and so on. It might be a little bit slower than the fast students. Would say, well, hey, I know that, I can do that, but again, it depends on the teacher. The teacher would make those decisions in the classroom setting as to who to call on to provide the answer. But in either case, tutor will take whatever answers is given, evaluate it, and do the proper thing next.
That's fantastic. One of the things that you said earlier that I think that a lot of teachers...
I think you've kind of gone down there. I'm not quite hearing you, Scott.
Let me see if wondering.
Yeah, it's a little better now, I think.
Okay. Skype sometimes will argue with us. One of the things that I really liked hearing, and I think a lot of teachers would really love to hear, is the automated lesson plans. That was always one of my very least favorite things to do. I knew what I was doing, but having to write it down and justify everything and then go look it all up, and that may be something for y'all to look into in the future, is aligning that with the state standards so that they can kind of be clicked and dropped in. A lot of folks would really love to be able to use it for something like that. Especially, I mean, and a lot of principals and states would like that too, because it would allow for standardization on lesson plans in a way that right now most people still use the black book where they write everything in every week. And that's
I haven't gone that far because, as I say, that's a fair amount of time, money, and effort to do it in a very systematic way. I would simply say that what we've done so far is not to try to mimic any particular curriculum, but to pick things that every curriculum must have. I mean, no matter what the curriculum has to be, for example, in math, there are certain basic skills that are going to be an integral part of that, whether it's solving algebraic equations or whether it's solving word problems or whatever. They're all going to be an important part of that whole process, and that's what we've done. There may be some gaps here and there, but hopefully, that can be filled in over time, and or teachers are going to be teaching things anyway, so they're clearly going to do that. But we're hoping to give them a good head start by picking the critical things that every student will need to know in order to be successful, at that grade level or whatever.
And I have some questions that more go to your broader expertise and experience rather than specifically on this. I mean, it'll, of course, be somewhat related just because of the type of product that it is. But you mentioned earlier that even quite some time ago, the goal for you and for others was never to replace the teacher in the classroom. It was to supplement and support. But there is still a camp in our field that believes that the best way to go about education is to kind of just replace the teacher, get them out of the way, because the human is the problem. They're the ones that create the issues in terms of the consistency of the outcomes, rather than recognizing what it is that the teachers do well. And so a lot of the bigger companies nowadays are going to the algorithms that you mentioned earlier. And I was reading an article last week where they talked about how the presentation of results in search engines can sway people even in small ways, but a number of them combined and paired up can sway things as big as elections. So they talked about some of the studies that they've done with political elections in India and Australia and elsewhere, where they had created a specific web browser, and when people would type in questions about political results, they could manipulate what order those were presented in. So if you just presented Hillary Clinton and Donald Trump at the top, when people would go to be asked about their opinions about political candidates in the United States, for example, they would always choose the top people, and they wouldn't challenge or question or critique the results. They weren't page 5 folks who were going to go more deeply in. The average citizen just looks at the first 1, 2, 3, 4, 5 results, and that's what shapes their opinions. Do we wind up having, as technologists, an ethical responsibility to be aware of this almost untoward control that we have over others? Because effectively we're all really unlicensed psychologists, since our field derives directly from psychology. What kind of ethical responsibility do we have to be aware of some of these effects that our systems that we build might have on our learners?
But we're certainly getting a little bit away from structural learning theory here.
Yes.
So I can only speak as an informed citizen, hopefully an informed citizen. What you're addressing is, I think, a big societal set of issues, problems. There's no question about that, and a lot of people are certainly concerned. And this is one of the big concerns about the, quote, adaptive learning movement, because it basically makes judgments, and I'm talking within the educational framework again, based on averages and so on. And there's just a lot that should not be, it's got to be based on the individual needs. And so, again, I keep going back to the fact that there are some things that every kid should learn that are really important. They're basic skills. There are other things that you cannot codify to that extent, and probably shouldn't, because they involve human judgment. They involve variation that really is essential, to success in society. And there are going to be inevitably differences among people. Not all students are going to be equally good in all areas, nor should they be, and so on. So we don't want a bunch of automatons, otherwise they wouldn't be people anymore. We just have a bunch of people that all did exactly the same things in the same way at the same time. And I don't know what kind of society that would be, but it's not one I think I want to be part of.
No.
So, it's sort of it is a combination of saying, gee, there are some things, however, that are very important to learn. There's certain things that are very important to learn in every area, just across the board. And then there are certain things that must be mastered and you have to be good at in particular areas. And it's those things that I think Tutor It and Author It are best able to handle and to provide for the education community and training community. Because if you've got certain things you want to make sure that they're done properly, then you better have something that will ensure that the people you hire or the people that you assign to do that job can in fact do it properly and to hopefully to some very high standard. That's the kind of thing and so on that I think Tutor It and Author It are best prepared for. And I think to make it a success, we just need to get more people engaged in using the technologies and essentially carrying it forward to its natural conclusion.
Well, and that gets to another question, and like we told the listeners earlier, we've done this before, so some of these are coming out of order versus what we talked about before, just because that's how conversations flow. But I have one of the questions that we talked about before is I was a public school teacher in Texas for 8 years. I was a technology specialist, English and social studies teacher, and No Child Left Behind came along as a direct result of what we were doing in Texas at the time, with a focus on basic skills and knowledge. And my entire job the first 4 years as a teacher was to simply teach to the test the entire time, because that's what we were told to do, because we were a low-performing school. It was difficult. But part of the underlying problem that I didn't understand as a teacher then, because I was still just learning to teach, I was learning about psychology, I was learning these things, so I didn't really have the words for it, but I knew that there was something missing with those folks. And so we build a lot of systems to teach content nowadays. But as I encounter the undergraduates that I design learning games for, as we use computer-based instruction like my IT lab for computer literacy, what I discovered with the first 4 years of the research with them is that they lacked any sort of self-regulated learning skills. They had no particular agency. It had been stripped away from them by the system that they had come from. The teacher was the font of all authority. They did what they were told. They sat in rows. And they didn't challenge any of that, which made it very difficult to have them engage in any of the types of learning that I thought were important, like problem-based learning from a social constructivist perspective. They had no motivation to do so. They just wanted to be told what to do. And then later on, as the No Child Left Behind kids came in, it wasn't just that they couldn't get the content or that they didn't have this impetus to do anything. They lacked basic self-regulation. They couldn't break down bigger tasks into smaller tasks because they hadn't been taught how. they didn't engage in time management because the teacher or their parents or whatever systems they were coming from did it for them. And if something in the system didn't remind them that something was due, they just didn't do it. And I'm seeing this bleed over now, not just from the undergraduates, but into master's and doctoral students as well, where I had an assignment due a few weeks ago in a doctoral level course. The system didn't have the due date pop up the way that it was supposed to. And so out of 10 students, only 4 actually did the assignment. And when I asked the students why they didn't do it, they said, well, the system didn't tell me. And by extension, that's your fault.
Sure.
Even though you told me 20 times in class this was due, it's not my responsibility to write it down. So one of the things about all these technological systems, and especially in the case of things like online learning, one of the things that has been consistently in the literature is that the students who do best in online systems, the students that do best with computer-based systems, are the ones that are self-directed, that are responsible, and have self-regulated learning. Is that something that we need to start looking at embedding in these tutorial systems, in these delivery systems, so that students have these prerequisite skills before we launch them into content acquisition?
I guess it depends on how you look at it. I mean, clearly, what you're talking about are really things that involve engaging in the real world, so to speak. And there's certain things. I mean, I can envision creating tutoring systems that would be designed to help people do that sort of thing. But for example, if it's a matter of going out to the library and picking up certain books, or making sure that something is done at a certain period of time and that sort of thing, that would be hard to automate within a given tutorial. I mean, on the other hand, and this is something that may be highly relevant here, in building tutorials, when you build a tutorial, what you're doing, just because of the nature of the way the system goes, and I didn't emphasize this time, I think I did last time, Scott, maybe it's a good time to phrase it. The whole system, the whole tutoring, authoring, and delivery system is based on the following 4 basic stages, if you want to think of it that way. One is how to represent knowledge, the knowledge that is to be acquired by this set of students who are going to be taught. Secondly is how do you find out what any given individual does and does not know or is able to do relative to that which needs to be mastered for success. And when you think of it in those terms, this that needs to be learned can be anything. It could be just doing something like column subtraction, or it could be performing any of the tasks that you're talking about independently. Now, you'd have to define those tasks. You'd have to define how to evaluate whether they did them and that sort of thing. But it's observable behavior, and theoretically could be certainly observed. But let me mention the other 2. Okay, 1 is representing what needs to be learned. 2 is finding out what a person does and is not able to do relative to what they need to learn. Thirdly is how they use the knowledge they have in the acquisition of new knowledge in that domain. And fourthly, how do you put it all together into a teaching learning system that will interact with the student and effectively work with them over time until they demonstrate full mastery. So theoretically, all of that is quite independent of what it is that's to be learned, whether it's something simple as in a well-defined math domain, or whether it involves the broader range of behavior you're talking about. So you'd have to say, for example, is the student able to do it himself? Does he, I even forget the specific task, but whatever that task is, if one identifies, there is associated with it a domain of behavior, or a range of behavior that needs to be demonstrated in order to demonstrate mastery or success in that domain. And if that domain involves showing up at the right time, or includes showing up at the right time for a certain purpose, under certain conditions and that sort of thing, That, in effect, is part of the domain you're defining. And then you have to say, in order to be able to do this, what does a student need to be able to do? What differentiates the kid who shows up and does that work and the kid that doesn't? Now, that domain can be very broad. And the typical problem is, how do you evaluate that on a computer? And some things obviously are easier to evaluate than others. But having said that, one of the things I want to point this out, with tutoring, when one builds a tutoring system, once it's been built, you can run that same, because you've identified what needs to be learned for success, whatever it is. And it could be putting a book on the third shelf next to the red one, and sort of thing. That computer's not going to know that and see it, but the student can in fact be told what to do or asked, what he's done. Has he done it properly? So if you had a complex task that had to be carried out, you could, for example, build one of these systems, and it could be run without any additional work as a performance aid. So not as a tutoring system anymore, but just a performance aid which says to the student, okay, we've got this task. Your job is to do X, Y, Z. Now let's get started. Do this first. Is this larger than that, or whatever the question is? If so, now do this. Otherwise, you're going to do something else. And so it would take them step by step through the process of actually solving any given class of any given task in that class of tasks for which the tutor was designed. So what I'm really saying here is you can define a tutoring system that is not necessarily limited to evaluation within the computer itself, that it can actually involve requiring the student to perform a task which is independent of the computer.
I like that a lot, and I'm glad we got back to that because that was really important last time. One of the other questions that I asked last time that I wanted to get back to, just because what you said really resonated with me, and this was when I was a kid. I lived in California. My friends were all playing video games, but my mom was a Montessori teacher, so she wanted me to play educational games. And they were friends with the Davidsons, who created Math Blaster and Reading Blaster and those kinds of very early learning games, lesser known back in that time than things like Oregon Trail or Lemonade Stand, which I also got to play. But have you had any experience studying any of these other kinds of tutorial systems that maybe have more of these kind of play characteristics, or any of the learning games or anything like that? Do you see much value in that kind of approach?
Well, I haven't spent a lot of time. I grandsons have spent quite a bit of time with learning games and so on, but I personally have not. However, there is one thing that comes through pretty clearly in playing games. I've certainly observed this with kids. As they play the game, they get better and better at it. I have a grandson who's extremely good, with playing some of those. I think you mentioned it last time, Scott. What's the
Minecraft?
Yeah. And this is a very widely used game. It's got a certain degree of complexity to it, and you can do all kinds of creative things with it. You can build all kinds of little entry points and mazes and things of that sort. And things really jump, and there's a lot of activity, and it takes work. I mean, you can't just get in there and do it. You certainly can't do, for example, what my grandson does. Now, the question is, from a broader perspective, how much of that has transferred value beyond the game itself? It's no question that kids get better at playing games when they play games, and they get good at them. The question is how to include or incorporate things of educational value. And if you're going to do that, you're right back in the same game, whether it's a game or whether it's a tutoring system. It's again boils down to identifying what do you want the kid to be able to learn, and building an environment within which will ensure that they will learn that. And it might be a game, it might be just a regular tutoring system, however you want to call it. But the bottom line is if you want kids to learn something, you really need to know what it is you're wanting them to learn. And if you do that, then you're going to succeed. Whether you do it, whether you call it a game or something else, I think the important thing is, what is it that is the target of playing the game? Some might be just enjoyment, and so on. I mean, moving things has certain skills, manual skills or a dexterity or what have you, moving things quickly enough and typing quickly enough or whatever it happens to be that's involved. And all of that, are skills, and there's skills that may have a certain degree of transferability. But I think if we're going to build these games from an educational perspective, or have that as an educational goal, then we really need to give more thought, I think, to what is it of value, of educational value, of long-standing value that we're trying to teach. If it's, able to manipulate the screen and work with the keyboard very quickly and things like that, that alone is probably transferable, and it's a useful skill. But is that all that we want, or do we want other things? And we need to, from an educational perspective, need to get better control over the situation. So we need to define, from my perspective, what it is we want people to learn, and it may include this kind of thing. And if it does, then we want to make that an explicit part of our educational system. But I think a lot of it, to be frank, is just keeping kids busy. They enjoy it, they have fun, and a lot of things in life are that. They go swimming because they enjoy swimming, or getting out, getting a little exercise, and so on. And all those are very valuable activities. The question is from the standpoint of, just take it very simply, if you're preparing kids to be able to be productive members of society, will that, to what degree will what you're doing contribute to their ability to make a living later on? For example, whether it's learning to program, or whether it's fixing a leak in a plumbing system.
Yeah, that's one of the things that I watched both my kids. My daughter primarily was the one that played Minecraft. But my son's gotten into it now more, and they're 6 and 9. My daughter, for a long time, she was very much focused on the pretty components rather than on really building anything. She would represent things, but it wasn't really towards an end goal. There was nothing that I could she was just getting better at playing the game, but not necessarily doing anything with it. But lately she's started to do things like engage with a programming component with Minecraft, where you learn how to program by doing it in Minecraft. And I think that that's a useful way of going about it. My concern with a lot of the computer-based systems that we're using now, especially as I read as a peer reviewer for journals and as an editor of a series on game-based learning, there's just this surface level focus on games rather than on the underlying structural components of what makes them work and why when people report about them. There's no definition of what a game is or an explanation as to what it is. It's this idea that if it looks like a game, that it's going to be motivating. One of my least favorite quotes, which I have used in my own work at times, is, well, we should go where kids are. If they're motivated by games, then we should use them because they appear to be motivating. And that's great. Extrinsic motivation is a good thing. But if we're not using strong underlying psychological theory to explain why learning is supposed to occur, and if the articles that are being generated if they're not explaining why learning is expected to occur, if we're not using consistent definitions for these constructs that we're building, then we're not really building the field. We're not building knowledge.
Yeah, I keep going back, Scott, to what is being learned or what needs to be learned, as said. If you want an effective educational system, you need to identify the important skills and capabilities and so on that you want the students to develop as a result of their schooling or training. And I'm thinking of it from a training perspective because I think certainly the work that we're doing goes well beyond just school learning. School learning is an important part, and a lot of our examples or tutorials deal with school learning. But having said that, there are a lot of things out in the field of work and so on that if you have somebody who you want to fix a plumbing leak or what have you, you want to make sure they know how to do it, and that they've got certain very specific skills and decisions and protections and so on that they have to be aware of and so on to do it in a way that doesn't ruin your house, so to speak. I mean, so there's a lot of things, all of them things to be learned that are important, and from our perspective, we want to be able to make it possible to convey that knowledge as efficiently as possible. As I say, whether it's higher order school learning or whether it is fixing a plumbing leak and doing it the proper way, that kind of thing.
Well, I guess one last thing, and I guess to kind of wrap up, and this gets more to how we're training and how we're thinking about getting to what we talked about before with the idea that teachers are better at particular things than machines are going to be. But our research tends to be, in many instances, decontextualized out of the naturalistic settings. We're not really going out into the field and studying the tacit knowledge of teachers, studying the processes, studying teaching and learning as it happens, the way that we
It's only so far you can go in that regard in a computer environment as well. So it's a combination of things, I think, of identifying what really is important, what are the essential skills in any particular training or educational program that you want to convey. And I think that's, again, why I think it's desirable to provide teacher control over those things, teacher and or school or curriculum supervisor, identifying what they feel is most important to be learned. And once you understand that, if one has an automated tutoring system, for example, that can ensure then that students will in fact master that, you've got close to the best of both worlds.
Would it make sense to start getting more of our doctoral programs reoriented towards engaging out with real world teachers? A lot of folks in our field tend to be a little introverted and a little geeky, and that doesn't sound super appealing, but that's kind of where everything's happening.
Yeah, I'm not sure, certainly that would be worthwhile. The thing that I guess I'd like to see, and of course this is from perspective of where we're working right now, we would love to see a bunch of skilled subject matter experts, instructional designers, and so on, essentially say, look, we've got a very powerful platform that can be used essentially for teaching anything or tutoring on anything. And what we'd like to do is to build an ever-expanding base of tutorials that will cover any and all of the kinds of things that people might want to go to, because once they have a large enough domain of possible topics, when people need to find something, they know where to look because there's a good chance that there will be things. And clearly, there's no one company, certainly not a small operation like ours, is going to be able to build all of these things. So that's why we focus so much on the platforms that make it possible both for creating these tutorials and for delivering them. And what we've done is minimize the work of creating these, because you do not have to tell the tutoring system what to do and when to do it. Tutoring, for example, knows, because it's based on structural learning theory, which makes it possible for it to make all tutoring decisions automatically independently of the specific content that's to be learned. So all the tutor or author has to do is to identify what needs to be learned to be successful in that domain. Once that's done, and you beautify it with whatever supplemental files or media you want to add, that sort of thing, ranging from your voice to videos or whatever, the system will then systematically take any student when they enter, find out what they know, what they don't know, and it's doing this over time and taking them from wherever they are, and will continue that process until they demonstrate full mastery, pretty much like a skilled tutor would do if they knew that subject.
I guess I'll close out with one last question for you. Is there anything out there that you're seeing in the field or things that appear to be coming up in the future that you're really excited about for supporting learning?
Well, I guess we'd say what we're doing is probably the most exciting from our perspective, because that's why we're putting so much work into it. But, I guess I was sort of, I don't know whether it was a planted question or otherwise, but yeah, clearly we put a lot of work into this, and it's based on pretty solid theoretical foundation, and so on, and that's what we're essentially trying to do. We're trying to create a authoring platform and delivery platform that will make it easy for authors to create dynamically adaptive tutoring systems with minimum effort in every possible area. And that's pretty much what our role is. And I know there are other avenues, and you've mentioned one, games and that sort of thing. We're not opposed to games by any means, but again, if one, from our perspective, the question would be, what is it that you want the kids to learn? If the game, you can construct a game which involves or encourages that learning, then it's worthwhile learning. And obviously, that's important. And our goal would be you could have a tutoring system to, for example, teach people how to play games as well. So there's no limit on the domain of applicability.
Well, and just a follow-up to that, and this is one of the things that no matter how many times I say it, I struggle to, I guess, get across, and you just mentioned it, which is that it is theory-based. Why is it important for an instructional design, for a product, for a treatment to be theory-based? What does it give us that failing to include theory kind of...
Good question. Good question. I think the best answer I can give, something that Norbert Steele said a few years back at a meeting we had, not just him, but it was at a convention, and we were talking, and I think it was a discussion group. But in any case, so why is it that we all start with these different sounding theories, and when you look at them, they all look the same? And what he was basically saying, I think, is that the theories were superficial, in effect, at the top level. And the decisions as to what differentiated them were made typically by programmers who really weren't that well versed in the broad-based theory that was guiding that work. The theories that were being used in instructional design for years, and I think this is almost universally applicable with the exception of the intelligent tutoring systems, and they made the opposite mistake. The people who were instructional design were essentially building theories that were vaguely right, but not very precise. And so the gap between the theory and the implementation was very large. And that gap was typically filled by programmers who didn't really fully understand the theory. And so the end result wasn't that differentiated. The other thing that was important, if you look back at a lot of the theories that have been talked about in instructional design, very few of them talked about the interaction process with the learner, the change in learning during the course of learning by interacting with the student. It's one thing to say you do this, and then you do that, and then you do this, and so on. For whatever reason, and we all know the various theories that have been proposed in instructional design for that purpose, but very little attention been given to finding out what the student does know at a given point in time and adapting the future instruction, to what the student knows when he's receiving that information. And that, from my perspective, is a critical essential. So that's essentially what we've been aiming to do. We've been building why the structural learning theory, because, frankly, right now, it's the only theory that is both generally applicable and vaguely right as well as precisely right, that deals with the system insofar as it's possible with existing technologies to create automated systems. We know that touch and feel, being able to evaluate full paragraphs the way a human would evaluate them, those are all skills that are beyond the current technology. Not beyond the current theory, but beyond the current technology. So what we're looking at is a theory that is broadly, universally applicable, but that it recognizes that at any given point in time, only so much of it can be implemented. There's a lot more I'd love to implement. If we had the resources, would be extending this work in ways that go beyond. But right now, we already have something that has hardly touched the surface, in terms of potential applicability. And that's what we're aiming for, and we want to get other people involved and contributing to that work, because there's an awful lot that can be done with what we've got right now.
Fantastic. Thank you so much. And you just helped me. Sometimes as you know from teaching, sometimes you have to have somebody else say it so that other people listen to it. And I really appreciate that.
Right.
And just generally, thank you so much for this, and thank you for doing it twice. I know that it was a big hassle for you to get the time to do this, especially twice. And the conversation has been wonderful, and I so loved getting to learn. I learned new things this time from the last time, and I think everybody's really going to enjoy listening to this conversation. And thank you so much. Is there anything else that you wanted to say before we head out?
No, just wanted to thank you, Scott, for the opportunity. I was going through this, actually, somehow or other, you know how it is when you do something the second time, it's never the same.
Yes.
And I hope I was sort of coherent and at least covered the points, the main points, and that people are interested, let us know about it, because we are really very actively interested in getting other people involved in achieving the goals, and that is basically building tutoring systems for everybody in the world on every subject.
You definitely have me interested, and you will probably see me this summer, especially after that talk about self-regulated learning that we just had. So thank you again so much, and hopefully I'll see you soon.
Thanks, Scott. Look forward to meeting you. Take care.